Okay, these notes are over factoring quadratics. So let's just jump right into this. No, thank you. All right, so factoring a trinomial is just reverse distribution. So what we do to be able to factor this quadratic is we multiply a, which here is 1, by c, which is negative 10. So 1 times negative 10 is negative 10. You're going to find factors of negative 10 that add up to b. So two numbers that multiply to give me negative 10 that add to give me negative 3 are negative 5 and positive 2. Because a is 1 here, we can just jump straight into saying that our factors are x minus 5, x plus 2, and call it a day. However, if a is anything other than 1, we cannot do that step right there. Okay, but since a is 1, that's good. We can jump straight into just saying our two factors. So here I have x squared plus 6x minus 16. So 1 times negative 16 is negative 16. I need factors of negative 16 that add up to a positive 6. So that's going to be 8 and negative 2. They multiply to give me negative 16. They add to give me positive 6. And since a is 1, I can go ahead and say that my factors are x plus 8, x minus 2. Again, we can only jump into that step when a is 1. If it's anything else, we can't do that. I have x squared minus 8x plus 16. So a is 1 times 16 is 16. I need factors of 16 that add up to a negative 8. So that would be negative 4 and negative 4. Negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. So we can write it as x minus 4 times x minus 4. Or how I typically write it is x minus 4 squared. Okay, this next one's a little different. It's x squared minus 81x. And the reason why this one's a little different is there is no b. There's no x in between the x squared and the negative 81. So this can be rewritten as x squared plus 0x minus 81. So 1 times negative 81 is negative 81. I need factors of negative 81 that add up to 0. So that's 9 and negative 9. So our factors are x plus 9, x minus 9. So anytime there is a b missing, you can plug in 0x for it. Now, when a is anything other than 1, we have some extra steps we have to do. Okay, so first off, I have 2x squared minus 11x minus 21. So I have to multiply a times c. So 2 times negative 21 is negative 42. And I need factors of negative 42 that add up to b, which is negative 11. So let me see here. 42. Okay, so 14 and 3, and the 14 needs to be negative. So negative 14 times 3 gives me negative 42, and negative 14 plus 3 gives me negative 11. So the only step that's different from here than the last one was a was something other than 1. So you have to remember to multiply the 2 times the negative 21, but then you're still finding factors that add up to b. Now this next part is different. So you're going to write out your factors as x minus 14, x plus 3. And there's a ton of different ways you can do this. I'm just showing the quickest way. You're now going to take what a is, which a is 2, and you're going to divide both of your factors by that. And if your 2 goes into the number nice and pretty, then you do that. So 14 can be divided by 2, and it's 7. So that factor is now x minus 7. 3 can't be divided nice and pretty by 2, though, so I'm going to take 2 and I'm going to pull it out in front of the x, so my second factor is 2x plus 3. That is the quickest and easiest way to factor quadratics. There's also by grouping. and we'll be factoring by grouping when we hit polynomials. But this, just for time's sake, this is the fastest way. So you take A and you divide both of your factors by A. If it divides nice and pretty, do it. If it doesn't, you have to pull A out into the front. So here I have 3x squared minus 2x minus 1. So I have to do 3 times negative 1 is negative 3. And I need factors of negative 3 that add up to negative 2. So that's going to be negative 3 and positive 1. So I can write out my factors as x minus 3, x plus 1, but then I have to go through my next step of plugging in A. So I'm going to divide both of my factors by 3. 3 can be divided by 3 nice and pretty, so I'm going to do that. So that's now x minus 1. But 1 can't be divided by 3 nice and pretty, so that 3 is going to go out into the front. So my second factor is 3x plus 1. All right, I have 2x squared minus 5x minus 12. So 2 times negative 12 is negative 24. I need factors of negative 24 that add up to negative 5. So negative 8 and positive 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So now I'm going to write it out as x minus 8, x plus 3. And now I have to divide both by A, which is 2. 8 can be divided by 2 nice and pretty, so that's now x minus 4. But 3 can't be divided by 2, so my second factor is 2x plus 3. I have 2x squared plus 7x plus 5. So I have to change pen colors. So I have to do 2 times 5 is 10. I need factors of positive 10 that add up to 7. So that's 2 and 5. So I'm going to write it out as x plus 2, x plus 5. And I'm going to divide both by A, which is 2. So 2 divides into 2 nice and pretty, so that's x plus 1. But 2 doesn't divide into 5 nice and pretty, so the 2 has to come out to the front, so it's 2x plus 5. I think I've got 1 or 2 more examples here. I have 3x squared minus 4x plus 1. So 3 times 1 is 3. Factors of 3 that add up to negative 4 are going to be negative 3 and negative 1. So I have x minus 3, x minus 1. And now I'm going to divide both factors by 3. So 3 goes into 3 nice and pretty, so it's x minus 1. 1 doesn't get divided by 3 nice and pretty, so I'm going to pull the 3 out into the front, so it's 3x minus 1. I think, this next example we have already done. Okay, so I'm not even going to worry about that one. Now, the way that you can check to make sure that you've done this correctly is you can FOIL your answer back together. So double distribution. So you can do x times 3x is 3x squared. X times negative 1 is negative x. Negative 1 times 3x is negative 3x. And negative 1 times negative 1 is a positive 1. So we have 3x squared minus 4x plus 1. So I ended up back where I started. So you can always multiply your factors back together, and you should end up with your original equation. And that is it for factoring quadratics.